Hello, everyone. Thank you for this opportunity to introduce our research project on agri-food soft robotics. Today, I'd like to discuss with you the big picture about what needs to be done in agri-food industry and how soft robotics could contribute to. Let me start with some of the reality check experiments that we are running in our laboratory. This is one of our collaborating companies in the UK. The company produces a large variety of vegetables in the large scales. This video shows one of the harvesting sites of the lettuces where hundreds of manual workers deployed for labor-intensive tasks. This company is actually technologically very advanced, and most of the production processes are automated. But still, there are many manual laborers which are the bottleneck of their business in terms of cost reduction and the further scalability. The manual labor costs are usually about half of the production costs, and they cannot be replaced for various reasons. This video shows a slow motion of what those manual laborers are doing. Each of these laborers essentially visually inspect the crop, harvest the crop, decide which leaves to be trimmed, and all of this need to be done in a fraction of a few seconds. Obviously, every lettuce is different, every leaf is different, and overall these tasks are not easy even for the most advanced robots in manipulator today. From technological standpoint, there are 5 different challenges. First of all the cost technologies need to be optimized because the industry has very thin profit margin and cannot afford too much investment in technologies. Second, robot manipulator needs to be a lot more dexterous and flexible to deal with large variety of target objects and environments. Sensing and understanding of objects with large variations is another big challenge. These robots need to delicately physical contacts while robust enough to long-term operation. And finally, robots are necessary to adjust themselves to various tasks, weather differences and environmental conditions. Looking at the various challenging problems in agri-food sectors, it seems that we need a paradigm shift in our robotics technologies if we want to make a big impact in this area. On one hand, there exist many solutions of automation that are already deployed in the business so far, which we can call Robotics 1.0. These robots are typically optimized for one single task, more efficient and cost-effective, and perfect for labor-intensive tasks in agri-food industry. On the other hand, there are many tasks remain for human laborers which require technology for Robotics 2.0. These tasks are more loosely defined, require flexibility, adaptability, sensing, and learning. Of course, many of these things can be possible with today's advanced robotics technologies, but these are simply not affordable in particular business sector we're working on at the moment. From this perspective, there has been an increasing interest in the use of soft robotics that is expected to provide technology for flexible, delicate, affordable solutions suited for agri-food industry. For example, in manipulation applications, soft robotics could provide a low-cost dexterous system for various food handling tasks, as shown in this picture. Although useful, we need to be aware of the fact that the softness would not solve everything, but a little more careful consideration is necessary. Among others, one of the significant challenges is to design soft rigid hybrid system where the system needs to switch between soft mode and rigid mode as necessary because they are trade-off nature of operation. More specifically, soft systems are good at structure flexibility and conformability, whereas not applicable for high power, rapid, precise control, and vice versa. We need a principle to design, operate soft rigid robot system, which are one of our challenges in our laboratory. The problem of soft rigid hybrid robot can be decomposed into three problems shown here. First, we need to figure out how to design, fabricate, and integrate soft rigid hybrid structure. Second, we need to create robust modular components such as sensors, actuators, and other fabricated structures that can be connected, integrated all together. Then we also need a systematic approach to generate and control diverse motion of soft rigid hybrid robots. I'm not going to go into the technical details of the three challenges, but I'd like to show you some of our recent research project in our laboratory. The first example we're showing is one of the promising technologies related to 3D printing, fabrication, and assembly. It is particularly interesting and important to highlight the fabrication technique of hybrid structures, which with a great degrees of flexibility and robustness. This slide shows that we have investigated how to replicate human-like complex mechanical dynamics of human like a skeleton hand by using multi-material 3D printers. By combining two types of material properties, we are able to demonstrate a flexible mechanical structure that resembles human behaviors, and this opens the door for the design and construction in the significantly more complex and integrated system for complex tasks. The studies of soft rigid hybrid robots have previously led to a development of automated food quality control system as shown in this slide. Food suppliers are currently struggling with the large volume of food samples to be tested manually by human laborers, but not easy to automate in the conventional technologies because of variations of crops as well as dexterous manipulation skills necessary. This system shown in this slide was developed in our group to make use of the particle jamming principles to grasp and release a large variety of foods for various quality control processes. This is a good example of how soft robotics could give an impact in agri-food industry for the important tasks. Another potentially important research challenge of soft robotics is to do with sensing. Integration of large amount of tactile sensor is a long-standing wish for soft manipulation applications, but no viable solution have been deployed yet. Here is one of our research efforts to develop low-cost soft sensing materials to be implemented into an anthropomorphic finger to demonstrate the sensing capability and soft manipulation. This kind of technologies can be applied to many applications of soft robotics in agri-food sector. This particular case study in this slide shows that how soft tactile sensing can be used for maturity analysis of hard shell fruits and vegetables. These fruits are typically difficult to analyze their maturity level by using computer vision because the color doesn't reflect the maturity level. But this is why it is usually tested by human laborers at the moment in industry in a destruction manner. This model-based approach of tactile maturity analysis opens the door for the large-scale sensing of crops in a non-destructive manner and possibly much better accuracy and the tractability of the quality control processes. There are many more cases and examples how soft robotics can give impact in agri-food industry, but here I'd like to give a quick summary of my talk today for the sake of time. In summary, I'd like to emphasize that there are many opportunities of application accessible because of the new development of soft robotics research and technologies. In particular, it is important to focus on the new materials, new mechanism, new fabrication methods that enable tasks that conventional rigid robots cannot do. Agri-food industry is very large and complex, thus there are many different ways how soft robotics could contribute. This table shows how we could make an impact in different ways in terms of yield increase, health and safety, traceability, sustainability, and cost reduction. There are many other ways how soft robotics could potentially contribute, which we should really investigate in the future. Generally speaking, soft robotics is giving impact at both material levels and basic principle level, which is the reason why it could give a large impact in this challenging problem in agri-food industry. Finally, I'd like to acknowledge our sponsors and the collaborators contribute to this content of this presentation. In particular, I'd like to acknowledge my co-workers, Josie Hugh, Luca Simeka, and Kieran Gilday for their great contributions so far. I would also like to advertise our Center for Agri-Food Robotics, where we're currently recruiting prospective PhD students in our network. If you're interested in studies in this area of research, please do apply. Also, I'd like to advertise our Soft Robotics Technical Committee, where we exchange various activities and information of soft robotics researchers community. If you're not a member yet, please do not forget to subscribe to the free bi-monthly newsletter from the website shown in this slide. With this, I'd like to conclude my presentation. Thank you very much for your attention.